Hey everyone, welcome back. So glad you could make it for the second session of our virtual workshop. Today, we are getting into the real nuts and bolts, the absolute alphabet of electronics. Once you know these 10 components, you'll really have the foundation you need to start building some cool stuff.
So let's just dive right in, shall we? I mean, from your smartphone to your TV, every single piece of tech is just a clever combination of these simple little parts. By the end of this, you'll be able to look at a circuit board and actually start to recognize what's going on.
Okay, we're going to start with the components that are all about managing the flow of electricity. You can think of them like the dams and valves in a river. Their whole job is to direct and control the power, making sure it goes exactly where it needs to at the right level.
First up is the resistor. Seriously, this is probably the most common component you will ever see. And its job is super simple. It just resists the flow of electricity. It's totally essential for protecting more sensitive parts and just, getting the right voltage levels in a circuit.
Now, this is where it gets interesting. This is a variable resistor, or what we often call a preset. So unlike a normal resistor with a fixed value, you can actually change its resistance, usually with a little screwdriver. This is awesome for when you need to fine-tune something, like maybe adjusting the sensitivity of a light sensor.
So, the main difference to remember is this. A standard resistor is like a speed limit that's set in stone. It never changes. But a variable resistor, that's like having a dial you can turn to change that speed limit whenever you need to. It gives you that extra bit of control. Next up, we've got the capacitor. This one here is an electrolytic type. The easiest way to think of it is like a tiny, super fast charging battery. Its main gig is to act as a filter, smoothing out any little dips or spikes in the power. And here's a crucial tip. See how one leg is longer? That's the positive side. You have to connect it the right way or it won't work. And this little orange guy is a ceramic capacitor. It pretty much does a similar job, smoothing out the power, but the big deal here is that it's non-polarized. That just means it doesn't have a positive or negative side, so you can just pop it in your circuit any way you want. Easy. All right, moving on to our second group, the gatekeepers and the amplifiers. Now, these components are a bit more active. Instead of just passively resisting or storing energy, these guys act like one-way gates or even powerful signal boosters. This is where things get dynamic. So this is a diode, and basically, it's a one-way street for electricity. Current can flow through it one way, but it is completely blocked if it tries to go backward. You'll always see this white or silver stripe on one end. That marks the direction the current can't flow back from. This is super important for things like converting AC power from your wall outlet to the DC power that batteries provide. Okay, meet the transistor. And I am not exaggerating when I say this is one of the most important inventions ever. This little thing is what started the entire digital age. It can do two main things. It can take a tiny electrical signal and amplify it into a much bigger one, or it can work as a crazy fast switch, turning on and off millions of times a second. It's the building block of pretty much all modern electronics. And when you're looking at a circuit diagram, there's a really simple trick to tell the two main types of transistors apart. It's all about the arrow. If the little arrow on the symbol points out, it's an NPN transistor. If it points in, it's a PNP. That one little detail tells an engineer exactly how it's going to behave. Pretty neat, right?
Okay, now we're getting to the really clever stuff. These next few components aren't just doing one simple job. They're actually entire, complex circuits that engineers have managed to shrink down and stuff into one simple little package. They're like the Swiss Army knives of electronics.
This right here is a voltage regulator. And let me tell you, this thing is a lifesaver. It does exactly what it sounds like. It provides a perfectly steady, constant output voltage. So for example, a 7809 regulator will always give you a rock-solid 9 volts out, even if the voltage you're feeding it is jumping around, say, at 12 volts or more. It keeps your sensitive electronics safe.
And that leads us to the big one, the integrated circuit, or IC. The whole concept here is just genius. You take a huge, complicated circuit, we're talking hundreds of components, and you photographically shrink it all down onto a tiny chip of silicon. The result is this little black chip, which saves you from having to build that massive, complicated thing yourself. You have definitely seen these a million times on your alarm clock, your microwave, everywhere. It's called a 7-segment display. It's simply 7 little LEDs arranged in a figure-8 shape. By lighting up different combinations of those 7 segments, you can make any number from 0 to 9 and even a few letters. So simple, but so effective.
Last but not least, we have the relay. A relay is basically a remote control switch. It's so cool because it lets you use a tiny, safe amount of power, like 5 volts, to control a much bigger, more dangerous amount of power. The small voltage powers a little magnet, which then pulls a lever to close a heavy-duty switch for something like a lamp or a motor. It's all about safely controlling big things with small signals.
And there you have it. Those are the 10 most essential electronic components. From the humble resistor all the way up to a complex IC, you now have your starter toolkit. You know the key players on the board. Seriously, think about what we just did. You've basically just learned the alphabet. And now that you know the letters, you can start putting them together to form words, and then sentences. And in electronics, that means building real working circuits.
So you better get ready, because in our very next session, we're going to put all this theory into practice. I will teach you about 5 basic projects, step by step, using the exact components we just learned about today. It's going to be a ton of fun. I can't wait to see you there.